Hello, everyone. Welcome to Audio Precision's Automotive Bluetooth Audio Test. Thank you for joining us today. Greatly appreciate your attendance. My name is Eric Hodges. I am the Director of Marketing and Sales Operations for Audio Precision, be your host and kind of the administrator here today. In just a few minutes, or just a moment, I'll be turning it over to Mike Martin. A couple administrative notes for us. We are recording this webinar, so please just be aware of that and know that we will make that recording available to you after the fact. Probably within the next day, you'll get an email with a survey to get your feedback on the webinar, but also to share you a link to the recording of the session. So number two, happy to take questions throughout the presentation. Just please use the chat window within Teams. I will be monitoring that throughout and interrupting Mike as the opportunity presents itself to relay your questions to him. And we will be saving some time at the end of the presentation, assuming we don't run right up against that 8 o'clock stop time, to field additional questions and have discussion. So again, use that chat window freely. And I think that is probably all we have from an administrative standpoint. So without further ado, I'm happy to introduce Mike Martin, our product manager here at Audio Precision, who's going to walk us through Automotive Bluetooth Audio Test. And I will mute up and kill my camera. Mike, take it away.
Thanks, Eric. Greetings, folks. It's good to be with you here. I am Mike Martin, as Eric said, and I have some roughly 30 years of test and measurement experience. I have an electrical engineering background, but today I'm the product manager at Audio Precision. And we're going to talk a little bit about Bluetooth tests for automotive applications, and primarily centered around head unit test. So with that, we'll move on. Here is our agenda today. I'm going to, in case there's anyone new to the topic, quickly kind of ramp up to a point where we can start diving into measurements. The unit that you see here on the screen is a single DIN head unit that we'll be using as an example DUT, device under test. So we'll do a brief intro to Bluetooth. We will talk about several aspects of Bluetooth to become familiar with those. And as we go on, we will ultimately get to the point of making measurements and talking about the results of those measurements. So that is our agenda for today. And maybe the first thing that's worth saying is that relative to Bluetooth in automotive, there's really two functions. There's a telephone interface, the hands-free phone interface, and there's the ability to stream audio data. And so what you see here is a phone and a audio streaming device that both could connect to this head unit in this particular car and communicate through the system. So just to start becoming familiar, if you aren't already, with the key elements, automotive Bluetooth really provides two levels of audio quality. One is the hands-free phone channel, which has about a 3.6 kilohertz bandwidth. That's not a lot of bandwidth, so it has an impact on the quality of the sound, but it does provide a two-way communication channel. And as you probably likely know, the other option is the advanced audio distribution profile, which provides near CD quality with a full 20 kilohertz bandwidth. That's a one-way communication. So in case you're not comfortable and familiar with profiles, I'll just mention that these are a set of functions that the devices use to communicate with each other. And without that common set of functions on both sides, you would not have a connection between the two devices. And as far as roles go, a device is either a source or a sink. Likewise, the test equipment will either be a source or a sink to match up to the device being tested. And so those are kind of the key elements of the actual Bluetooth connection and operation. So what we see here is a full set of all of the defined profiles that are available for Bluetooth. And out of these, there's actually 3 that are very specific to automotive. As I mentioned earlier, the advanced audio distribution profile, mostly referred to as A2DP. The audio visual remote control profile, which allows you to go back and forth in an audio track, bounce forward across a CD for various tracks on the CD. And finally, the hands-free profile. So these are the 3 profiles that are required for testing Bluetooth interfaces on head units. And so what we offer in the interface to our analyzer is the ability to select a set of these that provides the needed resource. And you can see here that this particular line gives us an A2DP source, an hands-free phone HFP audio gateway, and the remote control target. So this is a source setting, and there's also a sync setting for the same set of capability. So the device we're testing could take either role. So this is basically saying that we've got the elements necessary in the test system to properly communicate with these channels. All right, and here's a view of a couple of analyzers down at the bottom, and a closer view of the Bluetooth Duo module that goes into one of these analyzers. So we refer to both of these as modular analyzers. This particular unit has room for many modules, and this analyzer here, which is one of our newest, it's the APX 517 acoustic analyzer, it also has a module for Bluetooth or any other digital module you might want to put into it. So these systems are all capable of performing the kind of test we're talking about today. And the Bluetooth module offers both a source radio and a sync radio so that it can take on either role and perform the functions needed for a particular test. A couple of comments. One of the things that's really important as you dive into doing a test is to know your DUT. And this particular Sony device that we're testing has actually a lot of functionality and features built into a pretty small package, but it's one of the things that is special about it is that the hands-free phone channel is only available on the front speakers. It has a front and a rear pair of speakers outputs, and so to be able to test hands-free phone, you need to be connected to the front speaker pair during testing. And another thing that's kind of interesting, we'll talk about this more in a few minutes, is that the volume level is automatically reduced to minimum at power up. So it's just something you have to remember to go set up the power to the required level, the volume level. So the other thing is to know and understand a little bit about the profiles the DUT supports and potentially the codecs involved. I'll talk a bit more about codecs in a minute. And then getting ready to make the measurements, it's a matter of specifying the connections on the analyzer. We refer to that as the signal path setup. And so we'll be seeing that process here as we work through our presentation. So as you likely know from having used a lot of other Bluetooth devices, and I should stop and say for a moment, there's not really something that sets automotive Bluetooth apart from other Bluetooth devices. The test process and the steps taken to prepare for testing are quite the same. there can be different requirements depending on what you're trying to do, and extending out all the way to acoustic test in situ, so inside the car cabin. We won't be going to that extent in this presentation today, but those are the kind of things that start bringing in quite different territory from other elements. But there are three key steps involved, and one is for the units to go through a discovery process, and so once an item is discovered, we need to establish communication with it, and that is through a pairing process, which allows us to link up two devices and finally to connect. And once we're connected, we can start transmitting data back and forth. All right, so I think one thing that's worth saying is that this module that we have integrated into our analyzer is very integrated, and you'll see it often in the user interface and the elements that we have available to use with the analyzer that are specific to Bluetooth. So I mentioned the monitors up first, the status indicators up first, because it's something that's available all the time at the bottom of the screen that tells you what's going on with your inputs and outputs. And so here we see at the top a device is connected, and we are trying to do a hands-free phone connection. And right now, the SCO, or synchronous connection oriented link, is not connected. So this is a case where the status indicator is telling us we got a problem and we'll need to resolve it before we try to do any communication. So the line below that shows the expected condition for communication, which is the SCO is open, and we see the hands-free phone indication here. We see which codec is going to be used for the communication and what the bandwidth is. So this is information that's always available to you at the bottom of the screen. A little bit about elements that are involved here. Codecs are the way of coding and decoding the digital data, and there are variations in the quality of the data, the preservation of the detail in the data related to these. So it's good to know, and I'll circle back on this topic in a little while, good to know about this. So CVSD is continuously variable slope delta modulation. This is the most common codec used for hands-free phone and headset profiles. MSBC is the modified subband coding. This codec is mandated for wideband voice. So in the hands-free phone 1.6 spec. And so this is what the status indicator looks like for a sync. So here we have Bluetooth. This particular device is a Motorola device, and the profile is showing that, or sorry, here that we are doing A2DP high quality audio using the SBC codec, which is specified by the Bluetooth SIG or special interest group as a required codec available, the sample rate, and additional information. So we've got this information always right in line of sight while we're using the analyzer. If some status should unexpectedly change, it would show up on this indicator. All right, so with that, let's go ahead and connect to the analyzer and Bluetooth. And I thought before I jump into interfacing with the DUT, I would just spend a few minutes, in case you're not familiar with our user interface, to get you acclimated. And I'll mention as well that there are actually two user interfaces available. The sequence mode is standard. There is something called bench mode, which has a similar look, but is really designed for um, interactive R&D kinds of things. The update rates on the meters and displays are higher than they are in sequence mode. So it's a bit of a different tool. I'm not going to spend a lot of time talking about this today, but I will tell you that most of the things you can do in sequence mode uh, you can do here. And so, for example, I could reach up and select a Bluetooth connection for output and go through some Bluetooth testing in this mode. I won't be doing that today. I'm going to focus on the sequence mode.
Hey, Mike, while we're on in the UI there, and since you
Yeah,
just kind of left off with you're talking about the status bar, maybe point that out specifically where, since we're looking at the UI now,
yeah,
is.
yeah, right there. And so you can see that I've already got an output selected to Bluetooth here, and it's not connected to the device under test. So there's my first task. So if I reach over to my device under test, there's a button that says Bluetooth. I've already set the DUT for using Bluetooth communication, but I haven't set it up for pairing. So I'll hold this button down for about 7 seconds, and a little indicator on the display will start flashing. And as soon as it does, then I can continue on with this process. Now, there are often in our user interface, there's more than one way to accomplish the same task. So this little gear up here is associated with this connection, and I'm going to pop that open. And here we see kind of a profile set, so I can select what it is I'm going to be doing. And for this particular first step we're taking here, I'm going to go ahead and leave this in the source mode with this capability. And then there are another number of other elements that are worth mentioning here. SSP is a very convenient thing. It's secure, simple protocol, which allows pairing with or without having to do a pin. So the just works mode is really convenient. You don't have to stop and punch in some numbers to establish the communication. Not all DUTs will let you do that, but when you have one that does, it's a convenient thing. So normally when we select codecs, we can choose exactly which ones we want to use, or if we don't know which codecs the DUT supports, but we have a variety of them, such as you see here, we have the ability to prioritize the ones we would like to use most. And so, for example, I could decide, well, I'd rather have low latency as being my best option. So I've now shuffled these two. And if the device under test supports this particular codec, then we will establish communication using that particular codec. SBC is kind of a special case. The SIG group, as I mentioned earlier, has mandated that this would be available for all devices. So it's kind of the common denominator because not all devices have optional extra codec choices. In fact, this DUT that I'm testing today is a little old. It's been around a while, but it's still very relevant as far as the the way you communicate with it and test, but it only has SBC available for it. So that's a little bit about codec selection. For each of these, we have choices of sample rates, so we can, choose the settings that most closely match our needs. And you can see even SBC has selectable settings. All right, so that's kind of the top half of this in a quick flyby. The bottom half is really the process for making the connection. So if we scan for devices, it will show me all of the Bluetooth things that are in the area. And this explode item is actually our DUT. These are this is a Bluetooth speaker I have here in my office, and this, I'm not sure if this is a neighbor's phone or what that is. I don't recognize that particular device, but I select the one I want to talk to. And from this point, I can pair, and this one does not require a pin, so I don't have to worry about that. I just carry on. And now we are paired, and finally the last of those 3 steps that I talked about previously. So again, scan, pair, and connect is the connect step. And I generally select all profiles. I don't have to, I could select one specific, but by doing this, I have access to all 3, or all of the profiles based on what I'm trying to do with the analyzer. So at this point now, you notice that the status indicator has changed down here, and it's showing us that we have a A2DP connectivity using the SBC codec, and we're set for 48 kilohertz sampling.
Hey, Mike.
Yeah.
When making that connection and selecting the profiles, is there any downside to selecting the all profiles option as opposed to a specific profile?
Not that I'm aware of. I think there could be cases where you would want to force a particular mode and not allow for any deviation, just because you could, more carefully control what the DUT was doing and
So it'd be
focus.
a matter of isolating a specific profile that you wanted to evaluate, but selecting the all profiles, there's not a downside to that from a testing perspective.
Right.
Okay.
It makes the job easier because you don't have to remember, oh yeah, I need to go back and change those profiles. The system will track accordingly. All right, thanks, Eric. All right, so we're done with this. You notice there are other buttons down here, and we could have done a connection had we already had the other 2 steps done by just going straight here and clicking on the explode device. There are other actions that we can do, so we can manually start or stop the streaming of A2DP data, which we could do right now if we wanted to, but there's not really a need. We can interact with the remote control element, or we could do some of the activities associated with hands-free phone in a manual interaction. So these things are all here. Again, just trying to give you sight of the fact that often there are multiple entryways into the same kinds of functionality, just as a convenience. So let's step back here and just talk about this user interface a little bit more for anyone who maybe hasn't used our system. So this we refer to this as the APX 500 software, and it has the ability to do most all audio tests that are specified, and so we have created this system to make it possible to build sequences of test steps without having to use a programming language and all of the ancillary stuff that goes along with that. So what you see here are 3 panes. We see something called the sequence navigator pane, which is here. We see the signal path setup, which is about configuring the signal path, which is what it's showing right now. Or if we have a measurement setup, toggling over to set up a specific measurement element. And we'll see that some more here in a minute. This large area is the result display area. And you can see down here we have thumbnails of specific results that we could look at. And we have a number of elements that we can use with these. So for example, if I had a plot, and maybe I'll do this here in a few minutes when we get a response plot, I could open up cursors and have place cursors at points of interest and get readouts from them. So those are the key elements, but down here in the lower left corner is an interesting collection of monitors and meters. So we have essentially a scope display, so a time domain view of what's going on. And here you see it's simply just the noise that's in the on the lines at the moment. We have a spectral view and FFT view of the ins and outs, and we have a number of other things. So we have a metadata monitor, which if we're dealing with specific protocols, we can use to see the metadata that's being transferred. Going back to my earlier statement about level of integration, we actually have a Bluetooth monitor here. And we can pop any one of these out and have a closer look at it. So this one shows exactly what's connected and the status right now. Since we're using tongue twisted, A2DP, we have a active connection. It shows that. So we're basically ready to start streaming A2DP content based on this. So this is just one element that shows the level of integration on the system. Again, we have access to the actions, so we could connect or disconnect a device. We have access to the remote control command log if we wanted to see what was going on there. There's also an attention command log that if we need to look at, we can to see what's going on at a lower level with the system interaction. So this is the Bluetooth monitor, just one element of our implementation in Bluetooth for the analyzer. And so there are a number of these monitors we'll be using today. So at least the scope, the spectral display, and the Bluetooth monitor. All right, so that's a quick flyby of this interface. The sequence area is probably worth spending another minute or two on, and that is really to talk about specifying measurements and building up a sequence of steps that would be taken. And so we have kind of a default set of very commonly used audio measurements here, and we could select this and decide we were going to make these measurements, or we could uncheck them all and add a specific measurement that's more interesting to us. So this is something that's used often. This is showing all of the measurements that are available. And for each one of these measurements, there is often many results provided by the step, by the measurement. So we'll be looking at that in more detail here as we go. All right. I will mention that the system has a whoops, clicked on the wrong item there. The system has also a report that's produced at the end of testing that includes any graphical information that's produced and measurement results in this report. I'm going to turn this off. Normally we would use it, but I just don't want it popping up every time I choose to run a test. So I think that's a pretty good quick overview of this interface that we'll be using. We do have the ability to add additional traces, and we might see some of that as we go. So I think with that, let's go ahead and start making some measurements. So the first thing I would like to do is make a frequency response measurement on the device under test. Forgive me, I'm going to step aside a minute. Got a lot of background noise from the outside there. So what we'll do here is, so again, this is my entire list of measurements to choose from. And I'm going to choose a continuous sweep measurement. It's interesting. Getting some unexpected interaction between the two apps. And now what you can see is that I have this new measurement. I can select all of the results in this. So I'll see RMS level, which is kind of the primary thing. I'll actually be able to see the frequency response there. But I also have a number of other things, phase and whatnot. And so let's go make sure that we've got our measurements set up correct. So we defined an output from the analyzer of Bluetooth, and we've already got the codec selected from the stuff we saw before, but we could go look at it again. It's not necessary. We've already connected. So the input side of this is the actual speaker output from the head unit, and so I'm feeding that into two unbalanced channels here, stereo set. And if this was an acoustic interface that I was using, I could specify dB SPL target, and I could calibrate with TEDS, calibrate the microphone if needed. Of course, we're just doing an electrical test here, so we won't be using those capabilities. And I've got some other controls. So I think this is enough to get us started. But just one more thing we should probably think about here before we pull the trigger on making a measurement, and that is what's the output level of the device we're testing, because we would like to have a robust signal coming out of it. You know, usually the systems that you test are pretty good until you really start forcing up against the max performance. So I've got here the level set to -3 dBs FS. So this is a digital interface, the Bluetooth module. And so it's not dBV or dBm, this is dB full scale. And -3 is commonly used, and I'll actually show a case here where if you get much above that, the signal gets distorted. So I've got the scope monitor selected here. In fact, I'll even pop it out just to make it a little bigger for everyone to see. And I will turn on the generator. It's producing a 1 kilohertz tone right now. And if I thought, well, gee, I might want to test it at -2 or -1, I'm going to increase the signal, digital signal strength. And what we'll see here is that without very much change, the signal is clipped, and down here in the spectral view, you can see that the harmonic distortion is dramatically different than it was at 3. So -3 is kind of the sweet spot for this device. The other thing that I would want to do is make sure that my my gain on the DUT, the volume is up relatively high. So I can reach over and actually manually adjust the knob on the front panel. And we'll see the same sort of effect where I'll get up here to a point and then the harmonic distortion, the harmonics just kind of goes crazy and you can see the signal is clipped. So there's probably the maximum output that we would want to make tests with. Hopefully that's clear enough. So now we can, we've got this test configured, we've got this amplitude set up right. We can go ahead and run this sequence. And so we've got a number of tests selected for continuous sweep, a number of outputs, I should say, and we can run this sequence, a very basic sequence. All right, so we've run this test, and right away we see something that's unexpected. We would expect this because it's a digital system from the source and a reasonably designed device to, of course, be rolled off at low frequency, come up, be relatively flat, but we expect this to get out to 20 kilohertz, and it didn't. So something's gone wrong, something's wrong with our setup, and maybe one of the best places to start looking is the actual acquired waveform. So this is part of the normal output of pretty much every measurement that we make. And it's useful for cases like this to start understanding what's going on. And when I look at this, I see two things that are really sticking out like a sore thumb. One is that this continuous sweep, chirp if you prefer that term, should actually come to completion gracefully, and we should see the zero level out here at the other end. So we've got a time delay that's affecting our results, and in fact is specifically why we see the ringing right here. So we're going to have to correct that. And the other thing that's quite odd here is this. So something's happening at the beginning of the sweep that is upsetting the process. So what we can do now is go into the control panel for the continuous sweep measurement. And what we see is a pre-sweep that's set to 0, sweep time of 350 milliseconds, and some ability to extend the acquisition. So this one is kind of interesting to us because it's maybe going to take care of this problem out here. But we probably should try to understand the situation just a little bit better. And so one of the things that I can do is add another measurement here. And this time I'm going to add the DUT delay measurement. And I will need to make sure that I've got it configured the way I want. So our signal path is still good. And I can run this test locally. And here's what the system measures. So it determined that, and this is really common with Bluetooth devices in general, that there's quite a delay here in the system. So we need to compensate for that. And we could do it a couple of ways. One of them is to go into the system and on signal path, at the very bottom is a DUT delay. So we could go in and put 145 milliseconds, and that will compensate the acquisition. So if we go back now, and I haven't made the delay automatic, but I've entered in the information. If I rerun this sequence, we should see that part of this has improved. So there's something that's a little closer to what we would expect. Still not quite right because there's something happening up front here. So what we can do is adjust pre-sweep, and I might choose something on the order of maybe 200 milliseconds and start this. And it's especially disturbing to me that this discontinuity is here. What I expect is a very slow, gradual frequency increase from gradual and smooth frequency increase from 0. So let's run it again. And we've accomplished that. So now we see 2 channels. And by the way, the phase difference that you see here is intentional on our part. It's part of the system design. It allows for some optimization of runtime for crosstalk measurements. So I can actually align the phases if it's disturbing anybody to see that simply by setting crosstalk mode to none. And then,
Hey, Mike,
yeah,
so you mentioned the delay, and that's fairly common with Bluetooth devices and just the between the input and output. That 145 milliseconds, is that, is there a rule of thumb, or do you have any kind of gauge on the typical device, Bluetooth device delay?
it depends a lot on the device, and it actually can depend on the mode you're in when you're using the device. So changing codecs, there's latency involved in codecs. That's why we saw that one codec called low latency that affects the delays. But switching between hands-free and A2DP can show a difference. So it depends entirely on the setup, and you might find yourself going through this cycle a little bit in the initial setup.
But so a key takeaway then for anybody doing Bluetooth testing would just be delay as a potential gotcha, and maybe a good practice is to run that delay measurement before you really delve into the deeper measurements you want to make.
Absolutely. And we'll look at that a little bit more here in a few minutes as well. So now we've sorted out this. We have a very clean expected kind of chirp. And what we'll see back in the RMS measurement is something that's nearly perfect. I'm going to change this to dB just because I like to look at dB plots myself better. And if we look at the relative plot, this one's been aligned to 0 so that we can see a little more clearly. I'm going to just that one more time. We can see a little more clearly the alignment at 1 kilohertz of 0 dB, and we can see the roll off on both ends of this. Nothing sharp and unexpected out here in the system. So that's the basic getting a measurement up and running process. It's pretty common that you would find some tuning required. In fact, on this particular system, I would probably change this to something like 150 milliseconds. And I would likely even extend this out to something like 340 milliseconds. Isn't what I wanted. A little typo there. And so these timing features are pretty important for a given device. Once you get things set up reasonably, it'll be pretty consistent. So you won't find yourself flailing back and forth a lot with having to change these over and over again. All right. So we've created a single test sequence. We have other tests that are listed here that we haven't enabled, but I think for the sake of time, what we'll do is look at a more complete test. But before I do that, I promised I would show you an output report. So I'll just run this simple test again and let you see what the report looks like. So now it's generating the report. And here I see each test, in this case, one test, but multiple results from it, all cleanly displayed. Phase information. We forgot to talk about phase. It's kind of a nice feature. Sometimes getting phase data isn't as easy as it ought to be. So this report, you can choose it or not. It's a lot of really good data. Here's the phase plot, and generally we'll select it input to output, and I would auto scale this thing just to get all of the data on the screen. And then I might like to use a linear look at it. And what we see is the phase is extremely linear on this particular device under test. That's a good thing. We wouldn't really want to see a lot of wild fluctuations in this. So there's a little shot at that. Let's go ahead and open a more extensive project. I've got one here saved. And projects are simply, once you've specified a collection of tests that you want to do and expect to redo sometime in the future, you can simply save that. In fact, maybe that's the thing to do right now, is to save the project. And I'm off in the weeds at the moment. I'm going to just open here. I'll save it here, save the project. And you can see I've got a number of other ones, and I'll call this one my basic and save that. And now at any time I choose to, I can simply go back and recall that particular sequence of tests and rerun them without having to modify anything. Every control will be put back into exactly the state it's in at this point in time. All right, so let's go open. And I think we'll pick this one. And this isn't quite a realistic project that I'm opening up, because it has a lot of tests in it that are producing somewhat redundant results. All right, so we can look now at the tests, and I'm going to collapse things so that you can see the basic structure here. We have an A2DP section at the beginning, a hands-free sync section in the middle, and a hands-free source at the end. So here the DUT is acting in sync mode, and here the DUT is acting in source mode. So if we expand these, we can see exactly what's included. So I mentioned that there's kind of redundant steps. I've got a step frequency sweep, a continuous sweep, and an acoustic response test, all listed in the same area. There's a lot of overlap between the results of these, so we probably wouldn't, wouldn't do this in a normal thing. We would pick one test that we were confident in that would produce the results we want, and that would be the one we do. Um, so this is the A2DP, and we can actually continue expanding these out to see the rest of it. And what you'll see is that there's a lot going on down throughout this. Again, multiple tests here, and finally the last one with continuous sweep and a step frequency sweep. So there is an example sequence with more than just one basic test in it. And I will run this through and let you see some of the results. It takes a bit of time. Notice that our status indicator is telling us we're not connected. So one of the things that will happen is that we'll connect. And that leads us to kind of talk a little bit about signal path setup and to talk about the steps that can be taken as you go through the sequence. So,
Hey, Mike, sorry to interrupt.
yeah,
And you
go
just
ahead.
teed up something I was thinking of, is because you went and grabbed a different project file and opened that up. And obviously that's
Yeah,
one of the advantages of the APX software, is you can configure a project file and go back to it for testing, maybe not the same DUT, but similar types of DUT and using the same
absolutely.
methodology.
Yeah.
But from a Bluetooth perspective, if you had that saved project file, you open it up and you had just clicked start and run, will it, from a Bluetooth perspective, automatically do the connection and handshake, or is that still something you would have to do prior to running the sequence?
So for that test that we created from scratch, we would have to manually go through and do the connection. But what I'm about to show you is actually steps that can be done automatically as part of the sequence. And excuse me, I need to go through the steps that I did manually, but I would like them all to be automatic. And there's a feature in the system that allows installing or setting up sequence steps. And I'm going to give you a view of what's available in that. So you can put user prompts asking them to set switches. Like, for example, if this was a production test or something, we could have a step in here that a little message would pop up telling the operator, please hold the Bluetooth pairing button down for 7 seconds right now. That could be the way you might use that. There are lots and lots of things in this list, and basically what we're doing is allowing the user to build a sequence that would normally be achieved by using LabVIEW or C++ or some programming environment to do it. And here you don't have to program anything. You simply select the kind of thing you want to do out the sequence, place it in the right point in the sequence, and then when you run the sequence, that step gets done. So as I mentioned, sorry, go ahead, Eric.
Sorry, one included element of that, just to throw back, is you can also build in that DUT delay measurements, since we talked about the important.
Absolutely, yeah.
And then have the results of that applied to the rest of the sequence. Is that correct?
Absolutely.
Okay.
Yep. So in fact, this is, we could probably spend an entire day talking about the options and usage of the sequence capability here. But going back to my earlier comments about the level of integration of Bluetooth in the system, here is another indicator. I've got steps so I can actually tell it to connect, set transmit power on the module. I can go in and give specific commands to the the Bluetooth module in the analyzer to open a SCO, dial. So this is all hands-free, phone related. I can go into A2DP and start and stop streaming. And in each one of these is a step that can be placed in the sequence and would happen automatically every time I ran it. So what you see here is one of those steps already in. So we've got this DUT, and I'm going to run this. This sequence takes a little bit of time just because there are a number of tests that it does, and we'll probably have just enough time to run through this once and take a quick look at some of the output. But these sequence steps, and again, it's not just related to Bluetooth. It's the way you can put a lot of extra functionality. For example, you can set up automated equalization if you needed to do it through the use of the capability here. So I'm going to go ahead and run this, and you'll see what a little more complete sequence might look like. So the first thing that pops up is that I'm being asked to select the device I want to test, and here's the one that I recognize, and I hit OK. It's also allowing me to do some selection of codecs and profiles here. I don't need to change that. And now what we'll see is that it will carry on for some couple minutes here maybe, and
we saw the status bar change. The bottom as the connection was made is the first part of that sequence.
Thanks for pointing that out. And so now we'll do a step sweep. Step sweeps are really great because they're predictable and the signal dwells long enough that it's a very stable and repeatable measurement. It takes a little longer to do those than something like a continuous sweep. So there we did a 16-point plot of that data. And the next thing that will come is a continuous sweep. And that was a little faster. It's actually not quite done yet, but it'll be done very soon. That was the old data that we saw briefly there. And now we're doing an acoustic response test and a transfer function test. Might spend a moment more talking about that once this is completed. Now we moved into hands-free phone sync mode. And Eric, were you going to make a comment?
I was just going to ask, from a Bluetooth perspective, as far as, we're using, you can use the chirp sequence and or chirp signal or sign, but you could also be doing this with various forms of broadband.
Indeed. So that was part of my commentary for the very end. But yes, you're absolutely right.
Oh, I'm sorry. I didn't mean to steal your thunder.
That's okay. While we're waiting,
I love a good sine wave, but
while we're waiting for this to complete, we can talk about that. It's appropriate, especially for the hands-free phone tests, to use voice signals, and those are readily available. In fact, the analyzer software includes Polka source files that are exactly that could be used as a stimulus for the test of the hands-free phone link, and would give a more realistic representation of performance on real-world usage. So you're absolutely right.
And same thing for the A2DP as far as using some form of music file or
yes, absolutely. Yeah. And of course, built into the analyzer are other options like using noise sources, broadband noise sources as a stimulus. So you've got a lot of choices depending on what it is that you're trying to tease out from the testing that you're doing. All right, I think we're into the hands-free source, and we should be pretty close to being done here. So you can see I've accomplished an awful lot of test steps without having to do very much work. I now have a veritable mountain of data that starts back here with step frequency response that we saw at the beginning. So we've now done an awful lot of work, and the there were a number of changes like these that we looked at previously that went on during the process. So if I scroll down here to where we changed over to hands-free phone testing, there are some additional steps that were necessary to put it in that mode. So we send an open SCO control and a dial. And once we did that, the channel was open so that we could then start sending signals into the device through the hands-free path, including the appropriate codecs. So, so again, we've done lots of different tests on that, and we've produced output. And the thing that's interesting about hands-free phone is it's a very narrow channel. So you see that it's highly attenuated out here. You know, the channel is about 3.6 kilohertz wide, and beyond that, it's highly attenuated. So it's you know, doing mostly what we expected to do there. And of course, I've got these other elements. I won't spend a lot of time talking about it. If we were doing an acoustic-based test with microphones and all that stuff, we would probably primarily be using the acoustic response as the test vehicle for most of the results. And again, down here, a similar sort of process, again, with more sequence steps to change modes so that we could go into testing the source side. So we again opened the SCO, and we were able to send data from the hands-free link side of the DUT into the analyzer. All right, so the last thing, we're kind of out of time here, that I thought I would mention is the transfer function, and it's a relatively new feature in the system, but it really does look at the transfer function between the input to something being tested and the output. And what's especially interesting is coherence, which basically says ideally what goes in would be a verbatim copy, or the result coming out would be a verbatim copy of what went in. And if that were true, there would be a flat line at 1. And so any deviation is showing you what is happening with the DUT that is specific to it and not part of the transmit channel or receive channel of the analyzer, input or output side. So anyway, this is a relatively new feature. It's efficient, and it can be a good way to gather information that might not be readily available. It's great for testing digital microphones, PDM mics, and you can get out sensitivities of volts per full scale for the mics through this technique. It's a pretty cool capability. All right, I'm a couple minutes over. If there are any last questions, I'd be happy to take them. Other than that, thanks for your time and attention. If you've got additional questions, we're happy to receive those. And you can either contact me through Audio Precision, Mike M at AP, or you can contact our great technical support team who can answer probably a lot more questions than I could. All right, that's it for me.
Yes, well, thank you, Mike. It was great. As you're talking, I've pulled up a slide here that just has some good test and measurement resources for folks. Certainly, just starting up the website ap.com. Specifically, you mentioned our tech support team page, as you see identified there for contacting tech support. That has email or phone if you have technical questions. Just on audio test in general, about selecting the appropriate things. If you're an Audio Precision user, whether it's System 1, System 2, all the way up to the newest APX systems, they can help you out in that regard. Additional good resources are certainly our blog, some good articles there In fact, Mike's got one up there, a newly placed one on slew rate. And then checking us out, when we do publish new articles, whether they're on the blog or other areas, our social media feeds and our YouTube channel has some great technical videos, either in-depth audio test sessions or quick tips, which can usually last anywhere from 1 minute to 3-minute videos on using APX or a particular function or capability. I don't see any other questions popping up in the Q&A chat window, so I think that means we can just wrap things up. Thank you all for hanging with us. Sorry we ran just a little bit long. And again, if you do have follow-up questions, you can reach out to the tech support team or message@ap.com. Again, that's message@ap.com, general address, and we can funnel that over. If you had to say a question specifically for Mike or for me, we can get you connected with the proper resource. Thank you all for your attendance. I appreciate you joining us here today, and enjoy the rest of your day. Thank you.
Thanks, folks.